Holy cow, I got so excited about that last one, that last proof. Man, that was fun. Wasn't that fun? Gosh, that was fun. Hopefully got that idea. It's a parallelogram. We proved it. This is an example of a coordinate proof. This could have been proven using two-column proofs, a totally different method. Everything we're proving with coordinate proof, we could prove with two-column proofs. Just looks different. The format looks different. So here's the idea on this one. Again, I want you to find values of A and B. That little triangle there is equilateral. In other words, all the sides are equal, all the angles are equal. It's got tons of symmetry. A and B are the coordinates of that top point, that apex point. That's what I want you to find. And I'm going to give you the coordinates down here on the right. I'm going to call that point 8, comma, nothing. So this has got a mix of coordinates and numerical values. Go get ready, please. Thank you. Got to get those kids ready for biking. So pause this thing. See if you can find both of those. They're not that hard to find. They do involve radical answers. Hint. Spoiler alert. So the easy one is definitely A in this case. If you were to draw your line of symmetry there, your line of symmetry means this folds over. The line of symmetry is halfway. A is definitely 4. You're 4 units to the right, and you're going up some distance on here. Then it requires a little Pythagorean theorem here. You know this distance is 4. You don't know this distance here. We just know that's B. But you do know this distance here. And you know that distance right here because you can read. Equilateral is telling you how long this side is. It's telling you how long that side is. This is 4. This has to be 8. This has to be 8. It's an equilateral triangle. So a little Pythagorean theorem, and you should be able to find the value of B and simplify it. And this works for every equilateral triangle. You'll see this relationship in terms of locations on here. Every triangle, every equilateral triangle, this happens. It's going to be a big thing in math too. That distance should have been 4 rad 3. Should have been 64 minus 16, which is 48. And human calculator in your head, square root of 48, Asa. Bingo, 4 rad 3. That's the value of B. Hopefully those made sense. A little bit of Pythagorean theorem, using some things about symmetry, and of course, reading. I got one more kind of like that. If you remember what a rhombus is, rhombus looks something like that. A rhombus is like an equilateral triangle, except it has 4 sides. And it says here, a rhombus is a blank with blank. That's my little review here. It's a quadrilateral because it's got 4 sides with 4 congruent, 4 equal sides. Hopefully that makes sense. Let me give you where A and B are, though. So this bottom right is 13, 0. Give you some numbers for that one. The top left, and again, we're at 0, 0 here to make that easy. The top left is 5, A. You actually can get some points for this one right here. You know that distance, and you know this distance. That's 5, and that's 13, because that's 13. So that right there should be an easy point to get. I'm going to call it B, A. I'll let you figure out what B is first, probably. And A is a little bit trickier. You got to be on your ball game to get to A. All right. So rhombuses have 4 equal sides, which means this thing over here, this hypotenuse, got to be 13. This hypotenuse has to be 13. So you could draw an altitude here if you wanted to, and look at this little right triangle. Use some Pythagorean theorem, or you could do the same thing over here. Draw this little right triangle here. 5, 13. Little Pythagorean theorem, you can find that distance for A. Hopefully that makes some sense. And this is one of these beautiful Pythagorean triples where they all end up being integers. 169 minus 25 in your head, 144. Square root of 144, you know, is 12. There's your value for A. I mentioned B in the beginning was just 5 plus 13. B should be 18. Hopefully those both make perfect sense. Good luck. Hope this worked out well. There's a homework that looks a lot like this. Hopefully this gave you plenty of hints as to how to solve those. Enjoy.